That means the linear equation that we found before for this triangular plate, which describes this slope, is not applicable to describe this slope. So we have to find a different linear equation to describe this slope. To describe this slope, we will have two boundary conditions, which is this point, the coordinate is 0 for x and 0 for y. And the second point, which is at here, the coordinate for the x is b and for y is h. So we have these two boundary conditions determined. Now, with these two boundary conditions, we can find out the expression of y in terms of x, which is written right here. But let's keep in mind that this x is the x measured from this point to this point. To better explain this part, let me use a different figure to show you. Now, remember that in this configuration, we are finding the mass moment of inertia of this volume. Even though that this linear equation is shared by this lower triangle part, as well as the air above the slope, they all share the same linear equation. But we're not going to calculate the mass moment of inertia of the thin air here. We only calculate the mass moment of inertia of this volume down here. Which is why when we find out this linear equation, which is y equals h over b times x prime, this x prime is not the regular h that we use for the x-axis. That the reason is because when we define the y-axis, the value of y starts from this point and going up, and the value of x starts from the origin, this point, and going to the right. So the definition of x prime is not the definition of the x that we use right here. This is the definition of x prime, which is used in this linear equation. So we have to figure out that how do we convert the x prime to x. And this conversion is very simple because the summation of x prime and x equals the total length b. Therefore, x prime can be written as b minus x. And if you substitute the x prime into this expression, we have y equals h over b times b minus x. And then this can be written as y minus h equals negative h over b times x. And you just move this coefficient negative h over b from the right hand side to the left hand side, and you arrive this expression, which is the expression of x that we use right here. Right here. So if you compare this expression and this expression, they are the same.